Hello, welcome. Today we are here to discuss about the question called to remove duplicates from the sorted array. So given an array, we need to remove the duplicate values from the array. So the array is in sorted fashion. So what is the sorted fashion? Like here the array is in non-decreasing order. Okay, non-decreasing order in the sense the elements are not in a decreasing fashion. They are increasing, but we also have duplicate elements like this 3 and 3, 4, 4, 4. So this fashion is called as non-decreasing order. Yes. So we need to remove the duplicate. So for example, if we take an example, given a nums array 1, 1, 2, 3, 3, 4, 4, and 4. So we have to remove the duplicates and the elements are in sorted order. So keep this particular point in mind, guys. This will help us to solve this question in an optimized fashion. So just giving you a hint. Okay. So coming back, we need to remove the duplicates. What we need to remove? We need to remove the duplicate. So if you observe, so 1 and 1, we have 1 twice. So we are removing this 1. Okay. Now we have 2. Okay. Now we have 3 2 times. So remove this 3. And we have 4 3 times. Remove this 4 and remove this 4. So we need to return an array 1, 2, 3, 4, and remaining elements, don't worry. We'll just return this. So this should be your array after modifying or after removing the elements, and you need to return a value called k, where this k equals to, okay, where this k equals to count of unique elements. Count of unique elements. Unique elements in the sense, after removing, what are the elements left? The count of those elements. So in our example, what is that count? In our example, what is that count? The count is for these are the 4 elements which are unique, like in the sense unique after removing the duplicate. So we need to return this value 4 after modifying the array. After modifying the array in this fashion, we need to return this value k. Okay. Basically, what we are doing is we are simply whatever the unique elements are there 1, 2, 3, and 4. We are placing these 4 elements in the beginning of the array. Okay. These 4 elements in the beginning of the array, and we are simply returning the count of those elements. Okay. Whatever the elements are there, whatever the 4 elements that we have, okay, whatever the 4 elements that we have, which are there after removing the duplicates. Okay, the elements after removing the duplicates, its count we need to return. Okay, I hope this is clear. And now moving back to, let me just clear everything. Okay, just give me a second. I hope the question is clear. So basically, we need to remove the duplicates from the sorted array. That's all, pretty straightforward. Now, after seeing this question, okay, after seeing this duplicates, okay, after seeing that the array is containing duplicates, do you remember any data structure where it only stores unique values? Any data structure? Yes, that is hash set. That is hash set in Java, set in Python. Okay, hash set in Java and set in Python, where it stores only unique, where it stores only unique values. Okay, unique values. Now we are going to use that data structure as a brute force approach. So what we will do is, as we all know, for the first step is to find out the brute force approach. So after seeing this particular question, what will be the brute force approach, guys? We know, like, we have a data structure as a basic thing. We have a data structure which stores unique elements, right? We have this kind of data structure, right? So we will be using this unique data structure. What is the unique data structures, guys? What is the data structure that it stores? Unique values? Yes, absolutely correct. It is hash set. Hash set or set, you can call in Python. Hash set or set. This is the unique data structure. This is the unique data structure that we have in Java or in Python language, which will be used to store the unique values. Okay, this is the data structures that we have to store the unique values. Now, as we know, it only stores unique values. As it only stores unique values, what we can do, we can send all these values into a hash set. Okay, what we can do, we can send all this value to a hash set. What it will do, it will only contains unique values. So it will return me 1, okay, 2, and it will give me 3 and also 4. Only these 4 values, right? Only these 4 values. So what we will do, we will simply give all the values to hash set. What this hash set will do, it stores, it basically stores unique elements. It basically stores unique elements. So you give 1, it will store 1. And if you give this second one again, what it will do, already 1 is existing, so it will not store it repeatedly. That's all, guys. Simple, straightforward approach. Give the input to hash set. This will convert you, this will give you unique elements from the given numbers array, and you can store these numbers back into array and return that particular array. That's all. Pretty straightforward approach. Okay. So what it will give you is, you can simply store this back 1, okay, 2, 3, 4, and you can simply keep others as blanks, or whatever the existing values are there, you can keep them as is, and you have to return a k value, where k will be equals to size of the hash set. Size of the hash set. In our example, it is 4. So you can get k value from hash set size. So give all the elements into hash set. This hash set will give you a unique elements. Store this unique elements back into the array and return this k value. That's all, guys. Pretty straightforward and simple approach. And this will solve this approach. But what is the time complexity here? First thing we need to think of is, what is the time complexity? Okay. And what is the space complexity? So space complexity, as you all guys can see, that we are using this additional data structure hash set to store the values again. The worst case scenario will be, it can store all the n values where all the values are unique. Okay, suppose all the values are unique, all the values will be stored in the hash set, and the worst case space complexity is n. Okay, worst case space complexity is n. And time complexity, what will be the time complexity, guys? So hash set internally uses how it will be storing. Okay, how it will be storing internally. And if you consider all the calculations, okay, if you consider all the calculations, it will be something where it will be n into log n. It will be n into log n. So n elements, every time when you're storing the element into hash set, it will use log n time, and okay, plus n. Plus n. What is this n? You are storing back the elements into array. Whatever the hash set elements are there, you are storing back those elements. So further, the whole time complexity will be n log n plus n. So this space complexity is n, time complexity is n log n, which I think we can reduce these two things. Is there any possible way? Is there any technique that we can use? So just think of that for a second, guys. In the meantime, I'll simply erase these things. So let me just note down those steps for you too. So first thing is, so we have a data structure. So for the data structure, what we will do, which is hash set, we iterate on array and store all elements into hash set. Hash set. Okay, all elements will be stored into hash set. And after storing them, what we will do, after storing them, we have unique elements. Store hash set back to array from 0th index. That's all. And now return has set size. Return has set size. That's all. Pretty simple and straightforward approach. These are the 4 steps that we can simply follow to achieve this brute force approach. Okay. To achieve this brute force approach, we can simply follow this particular brute force thing, like the steps. First thing is to we have a data structure which is hashed. Iterate on the array and store all the elements into hashed. Store hashed back to array from 0th index of array. Return the hashed size. That's all, guys. I hope this is clear. Now, as I said, is there any better approach to reduce the time and space complexity? Is there any better approach, guys? Do we have? Just think for a second. Yes, we do have optimal approach. What is that optimal approach? Or how we can get this optimal approach? Here, again, we already know this technique. We already heard this many times, which is a two pointers. Two pointers technique. Okay. Two pointers technique, or you can simply call it as two pointers. We use two pointers to solve this particular thing. So how we use this two pointers, how we use this two pointers, and how we are going to store them and all, everything we will see now, guys. So before I proceed, pause this video for a second and just try to think of this approach, what we can do, how we can actually solve this. Like, just give it a thought, how we can use this two pointers. I gave you a clue. We will be using two pointers, but my question is how you will use this two pointers. Okay, these two pointers, how you will use. Just think for a second. So this is the example that we have. And for this example, the indexes are 0, 1, 2, 3, 4, 5, 6, 7. These are the indexes. Yes, these are the indexes. Now, as I said, we will be using two pointers, right? We'll be using two pointers. So we will have pointer 1 and we also have pointer 2. This is our pointer 2. We have two pointers. How we will use these two pointers? Now let's go through this, guys. Let's try to understand what we will do exactly. So we have two pointers. Pointer 1 will be pointing to index 0 and pointer 2 will be pointing to index 1. Pointer 2 will be pointing to index 1, guys. Now, this is your pointer 1 and this is your pointer 2. Now, when these two pointers are pointing to index 0 and index 1, are these elements same? Yes or no? Obviously, these elements are same. Now, when these elements are same, what we can simply do is, now, is there something that I can do here? The elements are same. What I should do? I should search for an element. I should search for an element which is not same as my first element, right? I should search for an element in the right half. Okay, I should search for the element on the right side of pointer 1, which is not same as 1. So, which is not same as 1. I need to search for that. So, I'll place my pointer 2 at index 1. Are these elements same? Obviously, they are same. So, what I'll do, I'll increase my pointer 2 to next position, index 2. Now, what is the element or what is the value that we have at pointer 2? The value is 2. The value is 2. What is the value that we have at pointer 1? Value is 1. Value is 1. 1 and 2. Are they equal? Are they equal? No, they are not equal. Now, I got two elements which are not same. I got two elements which are not same. Now, what should I do? I need to replay. I need to take this 2. I need to take this 2. I need to take this 2 and I need to place this 2 after my 0th index. After my 0th index. So this 0th index is nothing but after my P1. So after pointer 1, after pointer 1, we need to place this 2. We need to place this 2. Okay, let's do the same thing, guys. Now this will become 2. This will become 2. Okay. I now pointer 1 is pointing to 2, and this was updated to value 2 at index 1. And still my pointer 2 is index 2 only. Now let's move forward. Now pointer 2 came one step ahead. What is the value at pointer 2? It is 3. Value is 3 for pointer 2. What is the value at pointer 1? Pointer 1. Pointer 1 we have value is 2. Are they same? Are they same? No, they are not same. Now they are not same. We know that. So this is value 1. This is value 2, which got updated. Now, what is the value that is there at index 2, which is 2? We are not worrying about that. The pointer 1 value is 2. Pointer 2 value is 3. They are not same. Now, I'll simply update the index after P1 with newly found value, which is 3. I will update one step ahead index, which is index 2 with pointer to value. Pointer to value. Now, my P1 is pointing to where index 2. Now, my P1 is pointing to where my index 2. Okay. Now, P1 is pointing to my index 2. P2 is still pointing to index 3. Okay. P2 is still pointing to index 3. Now, again, I'll compare. What is the value at index 2? 3. What is the value at index 3? 3. They are same. So, I'll just go and search for the element which is not same as this 3. Okay, I'll move my pointer 2 again, one step ahead. Again, I got same 3. I got same 3. What I'll do, I'll simply move my pointer 2 to one step ahead. Because why I was moving my pointer 2? I was moving my pointer 2 to find an element, which is not same as pointer 1. To find an element which is not same as pointer 1. Pointer 1 is storing 3. Pointer 1 is storing 3 value. I need to search for a value on the right side which is not same as 3. So now I got it as 4. Now I got it as 4. Pointer 1 is 3. Okay. And pointer 2 is 4. Where they are not same. They are not same. Then what I will do, I'll update one index next. Okay. I'll update next index value with the pointer to value. I'll update this. This value will be okay, this value will be copied and updated with the next index of pointer 1. Okay, it will be copied to next index of pointer 1. Okay, now pointer 1 is pointing to this particular place. Pointer 1 is pointing to this particular place now. Okay, now again pointer 2. Pointer 1 value is, okay, pointer 1 value is 4. Pointer 2 value is also 4. They are same. I'll simply move one step again. P2 will be moved. Now again, pointer 2 value is 4, which is same as pointer 1. I'll move one step. Again, pointer 2 value is 4. I'll move one step. I reach the end of my array. I will stop this process. I will stop this process. Now, after this entire the process, what you can observe is I have 1, 2, 3, and 4. And 4 is being pointed by my P1. Okay, I have got my first 4 elements which are unique, which are having a count of 1 initially. Okay, I have removed all the duplicates in the first 4 elements, right? So now we need to simply return this P1 plus 1. We need to simply return P1 plus 1. Why I am retaining P1 plus 1? I have total of 4 elements. What is the value of P1? It is index 3. What is the value of P1, guys? 0, 1, 2, 3. Index is 3. 3 plus 1, which will become my answer 4. That's all. Pretty simple and straightforward tech. Right? Is this clear, guys? Yes. I hope this is clear. If not, let's take one more example. Let's do it again. So let me remove these things. Let me remove these things. Let me take one more example. Just give me a second. Okay. I hope this particular approach is clear to everyone. So we are moving up. Now we will take an example of, so elements are 1, okay, will not take 1, 10, 10, 10, 20, 20, 20. We only have 2 elements, guys, here. Okay. Okay, we'll just take 2 elements. That is fine. So for every element, let's give some space. Now this is 0th index, this is index 1, this is index 2, this is index 3, this is index 4, this is index 5. Okay, this is index from 0 to 5. Okay, coming back to our approach, we have 2 pointers, right? What are pointers we have? We have 2 pointers. This is my pointer P1. This is my pointer P1. And what I need to do, what I'm supposed to do, I need to search for an element 10. Okay, I need to search for an element which is not same as 10, which is not same as 10. Okay, not same as 10, guys. So I need to find out a value which is not same as 10 on the, where I need to find out on the remaining half, which is on the right side, basically, to be precise, on the right side. So I need to find out on the right sides. Okay. How I'll find? I'll take one more pointer, P2. Okay, I'll take one more pointer called P2. Okay. Before we proceed, guys, okay, why this P1 and P2 are working? There is one simple reason here. We know all the 10s are covered here. All the 20s are covered. Once I get 20, I don't need to figure out, I don't need to bother about these two 20s because this entire thing is already in sorted order. So I'll not miss out on any duplicate values. I'll not miss out on any duplicate values. That's the reason, just a small reason. Coming back to this, we have pointer 1 pointing to first index, which is index 0. And we have P2 pointing to first index. Why only first index? Because we need to search on the right side. We need to search on the right side. Okay. Yes. Now P1. P1 index is, let's take P1. Let's take P2. Okay. Now P1 index is, we are seeing the indexes 0. P2 index is 1. What is the value at index 0? What is the value at index 0? It is 10. It is 10. What is the value at index 1? That is also 10. That is also 10. Now 10 is equal to 10. Is this true, guys? Yes, obviously they are equal, right? At the end of the day, 10 and 10 are same, right? 10 is equal to 10. So what I need to do? What is the main approach of this P2? P2 should find a value which is not same as P1. Now 10 and 10 are same. What I need to do, I'll simply move to the next value. Now P2 is pointing to which index, guys? P2 is pointing to index 2. P2 is pointing to index 2. Okay. What is the value at index 2? Same 10. What is the value at index 2? 10 again. So now they are same again. P1 is pointing to 10. P2 is also pointing to 10. So I don't want that 10. I just go one step ahead. Now P2 is pointing to index 3. P2 is pointing to index 3. What is the value which is there at index 3? The value which is there at index 3 is 20. Now 10 and 20. 10 and 20. Are they same? No, they are not same. 10 and 20 are not same. So what we will do? We will simply, okay, we will simply move our pointer one step ahead. Why we are moving our pointer one step ahead? Because we know this 10 is only existing one time now. This 10 is only existing one time. So I will keep this 10 as it is, and the next value will be replaced. This value will be replaced with the newly found value at pointer 2. What is the value at pointer 2? 20. So this will be updated with, this will be updated with 20. So now this I will remove. I am removing this value, and now I will place 20 here. I'm placing 20. So this is pointed by P1 now. This is pointed by P1. So this 0 is updated to 1. And now after updating this to 1, we will simply update the value. Whatever the value is there at index 3, that value is brought to index 1. So value at index 3 is 20. This is brought to index 1. Okay, clear. Now what is the value what is the value of P1, guys? It is 1. What is the value of P2? It is 3. What is the value present at index 1? 20. It is not 10, guys. That got updated with 20. Now, what is the value at index P2, which is 3? That is also 20. They are same. I'll search for a new value on the right side again. Okay, P2 moved one step ahead, one step ahead. What is the value of P2, guys? That is updated to 4. That is updated to 4. Okay. What is the value present at index 4? That is also 20, which is same as our P1 pointing value. Okay, I'll again move one step ahead. This is P2. Now, this is P2. What is the value of P2 now? This is updated to 5. That is updated to 5 now. What is the value holding at index 5? That is 20, which is same as the value that is there at P1. So I'll move my P2 one step ahead again. I'll move my P2 one step ahead. Okay. P2 is moving one step ahead. Now, are there any elements? No, we reached the end of the list. So we will simply stop this process. What we are doing every time, we are comparing whether the values at P1 index and P2 index are same. If they are same, we are simply moving our P1. We are simply moving our P1 one step ahead. If they are not same, what we are doing? We are moving our P1 one step ahead and updating the value with P2's value. We are moving P1 one step ahead. Okay, we moved P1 from 0 to 1 and updated with the value of P2. Right? That's all. And then we need to simply return P1 plus 1. Why we need to return P1 plus 1? Because we need to return the count of elements. Count of elements after sorting. Basically, sorry, after removing the duplicates. What are the count of elements after removing the duplicates from the given example? Only 2 elements. Only 2 elements. And P1 is pointing to index 1, right? As you all know, arrays are 0-based index. So just adding plus 12. That's the only reason, guys. So that's all. This is what the approach is. Okay. I hope this is clear. Now we will jump to code part. Okay. This is the array 1, 2, 3, 4, 4. Now int count after removing duplicates equals to remove duplicates. We'll call a method where this method will take nums. Okay, this method will take nums. Now let's create a method and remove duplicate integer array nums. Okay, let's just cut this, we'll paste it above this. And what we need to do, we need to remove the duplicates, which means we have P1 and P2. Int P1 equal to 0, which is the first index, and P2 equals to 1, which is the first index. Now, while P2 less than length of the list. So we will simply pass this n also. And here we will also receive this n, length of the list. We have to move, we have to iterate. So if nums of P1 equal to nums of P2, if both the values are same, what we need to do? Increase P1, P2, sorry, increase P2, right? So P2 plus plus, that's all. If they are not equal, obviously else. If they are not equal, obviously it will go to else part. Now, P1 will move one step ahead. And update the P1's value. So now what we need to do? We will simply update nums of P1 with nums of P2. whatever the P1's value is there in the array, we will update that value with P2's value. That's all. That's all, guys. And after this, we will simply print the array. And then what we need to return here, we need to return P1 plus 1. Okay. And now system dot out dot println nums of I. Okay. Now let's just run this. One second, guys. Let's just make the static. Now we can see 1, 2, 3, 4. We just got 4 elements, but our array contains many elements. I hope this is clear. What we are doing is we are simply calling the method where this will return me the count after removing the duplicates. So we have 2 pointers where P1 is 0, P2 is at index 1. We are iterating till P2 is not reaching the end of the list. Every time if the numbers are equal, simply we are moving P2 one step ahead. Because why we are moving this is because we need to find out a element which is different from P1 index. And if they are same, increase P1, update it with P2. That's all. And then return P1 plus 1. Why we are using plus 1? Because this is 0-based index and we need count. P1 is pointing at a 0-based value, just increasing P1. That's all. I hope this is clear. Thank you.